Hello everyone, and welcome to our lecture on how to combine datasets in pandas. In this one, we'll cover 3 different ways to do this, and this will be either from merging, concatenating, or joining our datasets. As we'll be copying in a lot of different datasets for this lecture, instead of working through a separate notebook, we'll actually work through the existing notebook file, and I'll explain what all the code does as we go along. Let's go ahead and move over into our Jupyter notebook and get started. Okay, so here we are inside of our notebook file. If you want to follow along with me for this lecture, then this file will again be included in the pandas section folder, and it's just called Combining Datasets. At the top of this notebook file, I've gone ahead and imported NumPy and pandas, as well as created 3 small data frames which contain information on different employees. So their employee ID number, the department that they work in, their years of experience, and also their salary. If we take a look at these, we'll see that there's 4 employees inside of each data frame. And let's say that we want to combine these 3 small data frames into a single large data frame that contains all of our employees. To do this, we could use something called concatenation, which is a term that you might recall from our previous lectures. However, in the context of pandas, instead of using concatenation to join strings together, we'll actually use it to combine our data frames. So concatenation allows us to combine our data frames or series along an axis to form a larger consolidated data frame. It should be noted here that the shapes need to match along the axis that you're concatenating on. So basically, for vertical concatenation, the number of columns must be consistent, and for horizontal concatenation, the number of rows need to match. To concatenate our data frames, we'll just call the pd.concat function, and then inside of our parentheses, we can pass in a list of the data frames that we want to concatenate. So here, we've got df1, df2, and df3, which are the 3 data frames that we created at the start. By default, the axis that this function concatenates on is 0, which, as we've looked at before, axis 0 is for our rows. So now we've got a single data frame with all of the rows from our 3 small data frames, so containing employees from 1 to 12. If we wanted to join along our columns, we could pass in axis is equal to 1, and that will then concatenate along our columns instead. What happens here though is that we actually end up with a bunch of missing values, and that's because there's not any data available for these different columns. So for example, data frame 1 had data for our first 4 employees, but it didn't have any data for our other employees, which is why these are all NaN values. So basically, you'll need to make sure that the shape of your data frames line up before you concatenate them. Next up, we'll have a look at merge, which is another way of combining data from different data frames. If you have any knowledge of SQL, then mergers will feel very familiar as they work in the same way as SQL joins. And simply put, merging allows us to combine datasets by linking rows together using 1 or more keys. For this example, we'll use 3 data frames, which I've called left, right, and also a final one here called additional info, which we'll use later on. Our left data frame contains information on different products with their ID, name, and category. Our right data frame contains information on the price and brand of these products. And note here that it also contains the same product ID column. So we'll actually use this ID column here to merge our 2 data frames together. Let's have a look at how we could do this. To merge these 2 columns, we could just say pd.merge, and then we'll pass in the names of the data frames that we want to merge. So left and right. or just whatever your data frames are called. They don't need to be called left and right. Then we can specify the type of merge that we want to make, which by default is inner. If you don't know what inner means, then don't worry, we'll cover the different types of merge shortly. Finally, we can specify the on argument, which is just the column that we want to merge our two data frames on. Typically, you'll merge or join on what is called a key column, which we'll cover in greater detail in our section on SQL later on. But for now, just know that it's basically a column that is used to uniquely identify rows in a table. In this example, we'll use our product ID column. So each row from our two data frames will be joined or merged on the same product ID that they share. So from our left data frame, the item with a product ID of 2 will be merged with the product in our right data frame, which also has an ID of 2. And then we can see the result of this here. So now we've got the product name, category, price, and brand columns all in one data frame. And note here that we actually don't have any information for product ID 1 or 5. And we'll have a look at why that is shortly. Just to quickly show you, I mentioned before that by default, Pandas uses the inner merge. So we don't actually need to specify the type of merge. And also, Pandas will attempt to automatically select the correct column to merge on, which we can see here that it's done correctly. However, in some cases, it does get this wrong, so it's better to manually specify the column that you want to merge on yourself to avoid any errors. Okay, and before we move on to any more practical examples of the different merge types, let's take a minute to have a look at what the different types are and what they actually do. There are 4 main merge types to be aware of, and these are the inner, left, right, and outer mergers. You'll often hear these referred to as joins. And just to clarify this, in SQL, these are referred to as joins, whereas in Pandas, they are referred to as mergers. So if you ever hear people mention these terms, then they're actually talking about the same thing. We've already covered inner, which as we can see here from the description, it only returns rows where there's a match in both tables. We saw this in action before when our merge only returned products where there was a matching product ID in both tables. So product ID 2, 3, and 4. Next, we have the left merge, which will return all the rows from the left table and then the matching rows from the right table. Right merge does the opposite of this, so returning all the rows from the right table and then the matching rows from the left table. Finally, we have our outer merge, which will return all the rows from both tables. And then at the bottom here, there's also a helpful illustration to help you visualize how these work. Let's move back over into Jupyter and put these into practice. If we perform a left merge on our two data frames on the same product ID column, then this will return all of the rows from our left data frame, so product ID 1, 2, 3, and 4, as we can see here, but then the product ID of 5 from the right table will not be returned as this isn't a matching row. And also note here that the price and brand information is not available for this product, as this information was not available in our right table. So these are just an NaN value. For our right join or merge, then this will return all the rows from our right table, so product ID 2, 3, 4, and 5 this time, but product ID 1 is not included. And again, for product ID 5, we don't have the product name or category from our left table. Finally, we'll have a look at the outer merge, which, as mentioned, will return all of the rows So now we have product ID 1, 2, 3, 4, and 5, with product 1 and 5 having a few NaN values. And then it's also possible to merge a data frame again. So here we've assigned our merged table to a new data frame, which we could actually merge with our additional info data frame, which I've done here with the inner merge. Finally, we'll have a look at the join method, which shouldn't be confused with the mergers or joins that we've just looked at. The join method allows us to efficiently combine the columns of potentially differently indexed data frames. So the key difference here is that the join method works on indices and the merge types that we just looked at work on columns. For this example, we're using our same full data frame that we created before, but we'll join it with this new data frame containing some additional information on the quality of the item. So it's got two columns, the info ID and also a description. And note here that I've actually set a custom index. So instead of the default numeric index starting at 0 and going up 1 with each row, I've actually set it to the order of 0, 3, 2, and 1. When we join our two data frames, it will join on the row index. So we can see here with our data frame below, where the row index number was 0, the info ID and description are 101 and high quality respectively. But for our next row, which had an info ID of 104 and a description of energy efficient, this won't have joined with the next row from our additional info quality data frame, as the next row in that actually had an index of 3. Instead, it actually joined on the last row, which had an info ID of 104. So we can see here that the info ID and description of this row in our full data frame match up with the last row in our additional quality info data frame with an info ID of 104 and a description of energy efficient. And then it's gone through and done the same for the rest of our rows too. The key difference here is that merge works on columns and the join method works on indexes and index labels. Okay, and that there wraps up our lecture on how to combine datasets in pandas. In the next one, we'll finish off this section by having a look at some additional data frame operations that didn't fit nicely into any of the other lectures of this section. So you've done a really great job here so far. If you've got any questions, then please feel free to leave them down in the Q&A section below. Thanks everyone, and I'll see you all back in the next lecture.